Hello my dear students. Today we are going to solve another assignment number 13, and today's topic of discussion is electronic configuration. Let me revise you. When we say electronic configuration, what does it mean? It means the arrangement of electron in any atom. And there are rules to which electrons follow, and they take their positions to make the structure of the atom. So this is what we are going to practice today. So let us begin with the MCQs. The very first MCQ is how many electrons are used in covalent bonding the nitrogen molecule. First of all, you must be very clear about covalent bonds. These bonds result when mutual sharing of electron takes place, and the bond between two atoms is the resultant of sharing of two electrons coming from both of the bonding atoms. When we study the bond in nitrogen molecule, we come to know that nitrogen gas exists in a diatomic molecular form, in which two atoms of nitrogen are bonded to each other by 3 bonds. Each bond is the sharing of 2 electrons. So 3 bonds must be formed when 6 electrons are shared between nitrogen atoms. When we say 6 electrons means 3 pair of electrons. The second MCQ is what is the number obtained when the proton number is subtracted from the nucleon number? The proton number is the atomic number and the nucleon number is the mass number. And when we subtract proton number from the mass number, we simply get number of neutrons. So select the correct answer. Next MCQ is the valence electrons are present in dash. When we talk about valence means the outermost, and valence shell is that shell which is the outermost shell. So electrons present in valence shell must be the outermost shell electrons. Isotopes have same number of protons. Yes, very true, because number of protons become the identity of any atom of that element, and number of protons means atomic number. Same number of electrons. Obviously, when number of protons is same, number of electrons will also be equally same. Number of neutrons are different. Yes, that's very true about isotopes to know that isotopes are different atoms of the same element which have same number of protons but different number of neutrons. So I must be thinking to support D now. What are you waiting for? The next MCQ is atomic number is the, very to the point, that atomic number is the number of protons present in any atom. Theory section. What is electronic configuration? In the very beginning of this video, I explained it. The next part is why the electronic configuration is very important for a chemist to know. Yes, the key point of today's discussion. For any chemist, the electronic configuration is the only key to know about the chemical properties of that particular element. Because when we study the structure of the atom, all of the answers come out. So Knowing about electronic configuration is the information of that element at their atomic level and its structure. What are shells and subshells? The place or the region where electrons are found around the nucleus is called as shells, and these shells are also called as energy levels or stationary states. The very first shell is designated as K. It can have only 2 electrons in it, and it has the lowest energy level. The next shell is L, in which 8 electrons can be accommodated, but the energy level of the second shell, L shell, is higher than that of the first shell, that is K shell. The third shell is designated as M shell, which can be filled up with 18 electrons. It's the third energy state. And the fourth shell is N, which can be having, or 32 electrons can be accommodated in it. Now this is about the shells. When we ask what are subshells? Subshells are the further divisions of shells. As we know that electrons revolve around the nucleus on the circular orbits or circular paths on the basis of having different amount of energies. But subshells are the divisions of shells. So the first shell, that is K. Both of the 2 electrons of K shell reside in S subshell. L shell, the second shell, having 2 subshells, S and P. And M shell has S, P and D in it. And N shell, the fourth shell, has 4 subshells or sub-energy levels, S, P, D and F. Now when we sum up all the information about shells and subshells, we have to learn one thing, that S subshell can have 2 electrons, P subshell can have 6 electrons, D subshell can have 10 electrons and F subshell can have 14 electrons in it. Write the electronic configuration of the first 18 elements in the periodic table. This is a very routine practice which teachers focus when they explain electronic configuration. And this is how we write the electrons, or we fill up electrons in the orbits or in the shells. You just remember one thing, that we cannot fill electrons on our own choice or liking. There is a rule to which every electron is following. That is off-bow rule. Now, similarly or simply, we can talk about the filling of electrons by this pattern: 2, 8, 8. Like whenever you are going to write the distribution or arrangement of electrons in any atom, the first shell will be filled up with 2 electrons only. Second shell will be following, accommodating 8 electrons in it. And the third shell will be accommodating 8 more electrons into it. So what are you waiting for? Just get the symbols and the atomic numbers from the periodic table and write the electronic configuration on the same pattern. Suppose I explain the configuration of lithium here. Lithium is the element whose proton number is 3. Now according to the given pattern, I have to arrange these 3 electrons. So I will write 2 in the first shell, because first shell can have only 2 electrons. Then as I am having only 3 electrons in the shell and I am left with only 1, so I will be putting that third electron in the second shell. Similarly, if I'm going to write the configuration of sodium. Sodium is another very important element of group 1A whose proton number is 11. So now this time I am having 11 electrons to arrange. Now as per given pattern, I will put 2 electrons in the first shell. Second shell will be accommodating 8 electrons. Now I have just one more electron to be accommodated, and that is going to be placed in the third shell or third orbit. So this is how you will practice one by one electronic configuration till 18. Now the next question is, draw dot and cross diagram of methane and water. For this practice, you need to write the correct molecular composition of the compound methane, that is CH4. Now the carbon is the central atom. Look at the number of protons in carbon atom. Now out of these 6 electrons, only 4 electrons are present in the second shell. So we are going to write only the outermost electrons or the valence electrons. So this is how carbon has 1, 2, 3 and 4 electrons. As there are 4 hydrogen atoms and each hydrogen atom has only 1 electron because the proton number of electron is just 1. So for the sake of convenience, I will draw that electron using a cross. So as there are 4 hydrogen atoms, 4 crosses will be drawn. Now I have shown all of the bonding electrons using dot and cross. So this is the dot and cross formula for methane. Similarly, practice the dot and cross diagram or formula for the water molecule. Let me help you here if I tell you that the composition of water is H2O. H2O means O is the central atom, oxygen is the central atom, and it is bonded to 2 hydrogen atoms. You have to see what is the proton number of oxygen and how many electrons this oxygen atom has in its outermost shell. Okay, now we see the last question. Why do atoms try to achieve the electronic configuration of a noble gas? So this is what we have to give the reason for all of the changes in electronic configuration. You know, all elements try to achieve stable most electronic configuration, that is of noble gas. Except helium, all of the noble gases have 8 electrons in their outermost shell. Means they have octet electrons in their shells. And having 8 electrons means they are following octet rule, and it's the sign of stability. And all other elements which do not have completely filled orbits, they try to get them filled either by taking electrons or by giving electrons, or sometimes they start sharing the electrons between them just to be noble, as neon, argon and so on. Now you have to write the configuration of neon and argon, and I'm sure that when you write the answer of first 18 electronic configurations of elements, you will get your answer already done with you. I'm leaving you with the hope that this discussion will be very helpful in writing or solving this worksheet. Thank you. God bless you, class. Take care.